correct sizing of conductors for a temporary electrical service is paramount for safety and code compliance. The situation describes an existing temporary service comprised of a meter with 4/0 aluminum conductors on both the line and load sides. The load side feeds into a gutter, from which two sets of number 2 copper conductors are tapped, each set leading to a 100 amp single-phase panel. The primary concern arises from the ampacity of the 4/0 aluminum conductors. According to the National Electrical Code Table 310.16, 4/0 aluminum conductors are rated for 180 amps when used in typical applications with an insulation temperature rating of 75 degrees Celsius. This rating is based on specific conditions and insulation types, which must be verified in the field. The critical point is whether 180 amps is sufficient to supply two 100 amp panels. If both panels were to draw their maximum current simultaneously, the 4/0 aluminum conductors would be overloaded. Overloading conductors can cause them to overheat, potentially leading to insulation failure, fire hazards, and equipment damage. It's important to understand the concept of ampacity, which is the current carrying capacity of a conductor under specific conditions without exceeding its temperature rating. The NEC provides ampacity tables to ensure that conductors are adequately sized for the intended load. In this case, since the combined potential load of the two panels is 200 amps, the 4/0 aluminum conductors are undersized. The recommendation to use 250 kcmel aluminum conductors or larger is based on the need to meet or exceed the total load demand while adhering to NEC guidelines. The kcmel unit refers to 1000 circular mils, which is a measure of a conductor's cross-sectional area. A larger kcmel value indicates a larger conductor and, consequently, a higher ampacity. Consulting NEC Table 310.16 again, 250 kcmel aluminum conductors typically have an ampacity of 255 amps at 75 degrees Celsius, which is sufficient to supply the combined 200 amp load of the two panels with some margin for safety and potential future expansion. It's crucial to select the correct conductor size not only to prevent overloads but also to minimize voltage drop. Voltage drop occurs when the voltage at the load end of a conductor is less than the voltage at the source end due to the conductor's resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for feeders and 5% for branch circuits. The length of the conductor and the amount of current it carries both affect voltage drop, so it's important to consider these factors when selecting conductor size. The suggestion to change the main breakers in the panels to 80 amps is not an acceptable solution for several reasons. Firstly, simply reducing the breaker size does not address the underlying issue of undersized conductors. The main breaker is intended to protect the conductors from overcurrent, not to limit the load to a value below the conductor's ampacity. Secondly, reducing the breaker size may not be practical or safe. The panels may contain circuits that require more than 80 amps of current, and reducing the breaker size could cause nuisance tripping. Thirdly, the NEC requires that the main breaker be sized to protect the conductors in the system. Using a smaller breaker would violate this requirement. Furthermore, the NEC specifies rules for conductor protection in section 240.4. This section outlines the requirements for overcurrent protection of conductors, including the use of circuit breakers and fuses. The general rule is that conductors must be protected at their ampacity, with some exceptions for specific applications. It's important to note that temporary electrical services are subject to the same NEC requirements as permanent installations. In addition, temporary services may be subject to additional regulations or inspections by local authorities. The temporary service must comply with all applicable codes and regulations to ensure safety and prevent hazards. Grounding is another critical aspect of electrical safety. The grounding system provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and clear the fault. A properly grounded system helps to protect people from electric shock and prevent equipment damage. The NEC specifies detailed requirements for grounding in Article 250. These requirements cover the grounding electrode system, equipment grounding conductors, and bonding. It's essential to ensure that the temporary service is properly grounded in accordance with the NEC and local regulations. Bonding is the process of connecting all metal parts of the electrical system together to create a common ground potential. This helps to prevent voltage differences between metal parts, which can cause electric shock. The NEC requires bonding of all metal enclosures, raceways, and equipment. This is typically accomplished by using bonding jumpers or grounding conductors. Regular inspections and maintenance are essential for ensuring the safety and reliability of the temporary service. The temporary service should be inspected regularly for signs of damage or deterioration. Any damaged or defective component should be repaired or replaced immediately. Maintenance tasks may include tightening connections, cleaning equipment, and testing grounding systems. Furthermore, it is important to consider the environmental conditions in which the temporary service will be used. If the service will be exposed to moisture, corrosive substances, or extreme temperatures, it may be necessary to use conductors and equipment that are specifically rated for those conditions. The NEC provides guidance on selecting conductors and equipment for various environmental conditions. It is imperative to consult with a qualified electrician or electrical engineer to ensure that the temporary service is designed and installed in accordance with all applicable codes and regulations. An experienced professional can assess the specific requirements of the site, select the appropriate conductors and equipment, and perform the necessary calculations to ensure that the system is safe and reliable. In summary, the 4/0 aluminum conductors are undersized for supplying two 100 amp panels. Using 250 kcmil aluminum conductors or larger is the correct solution. Changing the main breaker size is not an acceptable alternative. Adherence to NEC guidelines and consultation with a qualified electrician are crucial for ensuring the safety and code compliance of the temporary electrical service. The analysis requires careful consideration of several key factors, including conductor ampacity, overcurrent protection, grounding, bonding, and environmental conditions. The NEC serves as the primary reference for determining the appropriate requirements for each of these factors. It is important to understand the relevant sections of the code and to apply them correctly to the specific application. In addition to the NEC, local codes and regulations may also apply. It is essential to check with the local authorities to determine any additional requirements that must be met. The electrical system should be designed to meet or exceed all applicable codes and regulations. Finally, safety is paramount. Always follow safe work practices when working with electricity. Wear appropriate personal protective equipment, such as gloves and eye protection. De-energize circuits before working on them whenever possible. If you are not qualified to work on electrical systems, hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. In the context of temporary electrical services, several specific considerations must be taken into account. Firstly, temporary services are often used in demanding environments, such as construction sites or outdoor events. These environments may expose the electrical system to moisture, dust, vibration, and other hazards. It is important to select conductors and equipment that are suitable for these conditions. Secondly, temporary services are often subject to frequent changes and modifications. As construction progresses or event requirements change, the electrical system may need to be reconfigured. It is important to design the system in a way that allows for easy modification and expansion. Thirdly, temporary services are often used by a variety of personnel, some of whom may not be familiar with electrical safety procedures. It is important to provide adequate training and supervision to ensure that all personnel are aware of the potential hazards and how to avoid them. The design and installation of a temporary electrical service should take into account the specific requirements of the site, the expected load, the environmental conditions, and the qualifications of the personnel who will be using the system. A thorough risk assessment should be conducted to identify potential hazards and to implement appropriate safety measures. The temporary service should be inspected regularly to ensure that it is in good working order and that all safety measures are in place. Any deficiencies should be corrected promptly. Furthermore, when dealing with aluminum conductors, proper termination techniques are essential. Aluminum expands and contracts more than copper with temperature changes. If connections are not properly made, this can lead to loose connections, increased resistance, and overheating. The use of appropriate connectors and antioxidant compounds is crucial for ensuring reliable and safe connections. These compounds help to prevent oxidation of the aluminum, which can increase resistance and reduce conductivity. The NEC provides specific requirements for terminating aluminum conductors in Section 110.14. These requirements cover the use of listed and labeled connectors, the application of antioxidant compounds, and the proper tightening torque. It is important to follow these requirements carefully to ensure that the connections are reliable and safe. Furthermore, it is essential to use tools that are specifically designed for working with aluminum conductors. These tools can help to prevent damage to the conductor and ensure proper connection. For example, torque wrenches are used to tighten connections to the correct torque value. This helps to prevent over-tightening, which can damage the conductor or connector, and under-tightening, which can lead to loose connections. When selecting conductors for a temporary electrical service, it is important to consider not only the ampacity but also the voltage drop. Voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for feeders and 5% for branch circuits. The voltage drop depends on the length of the conductor, the amount of current it carries, and the conductor's resistance. The resistance of a conductor depends on its material, size, and temperature. Aluminum conductors have a higher resistance than copper conductors of the same size. This means that aluminum conductors will experience a greater voltage drop than copper conductors for the same load and distance. To minimize voltage drop, it may be necessary to use larger conductors or to run shorter circuits. The NEC provides formulas and tables for calculating voltage drop. These resources can be used to determine the appropriate conductor size for a given application. Also, remember that the NEC is updated regularly, typically every 3 years. It is important to use the latest edition of the code to ensure that the electrical system complies with the most current safety standards. The NEC is a complex document, and it can be difficult to understand and apply all of its requirements. If you have any questions or concerns about electrical safety, it is always best to consult with a qualified electrician. They can provide expert advice and guidance to ensure that the electrical system is safe and compliant. In addition to the technical aspects of conductor sizing and overcurrent protection, it is also important to consider the administrative and logistical aspects of temporary electrical services. This includes obtaining the necessary permits, coordinating with other trades, and managing the temporary service throughout its lifespan. Obtaining the necessary permits is an essential step in the process. Most jurisdictions require permits for electrical work, including temporary services. The permit application will typically require detailed information about the electrical system, including the location of the service, the size and type of conductors, the overcurrent protection devices, and the grounding system. The permit process may also involve inspections by local authorities to ensure that the electrical system complies with all applicable codes and regulations. Coordinating with other trades is also important. Temporary electrical services often need to be integrated with other systems such as plumbing, HVAC, and fire protection. It is essential to coordinate with the other trades to ensure that the electrical system does not interfere with their work and that all systems are compatible. Managing the temporary service throughout its lifespan requires regular monitoring and maintenance. The electrical system should be inspected regularly for signs of damage or deterioration. Any damaged or defective component should be repaired or replaced promptly. The temporary service should also be tested periodically to ensure that it is operating correctly and that all safety measures are in place. The termination of a temporary electrical service also requires careful planning and execution. Temporary service should be disconnected from the power source in a safe and orderly manner. All conductors and equipment should be removed from the site and disposed of properly. The area where the temporary service was located should be cleaned up and restored to its original condition. The process also needs to consider the potential for future use. In some cases, a temporary electrical service may be needed again in the future. In these cases, it may be possible to leave some of the conductors and equipment in place for future use. However, it is important to ensure that the conductors and equipment are properly protected and that they comply with all applicable codes and regulations. This requires a comprehensive approach that considers not only the technical aspects of electrical engineering but also the administrative, logistical, and environmental aspects of the project. By following these guidelines and consulting with qualified professionals, one can ensure that the temporary electrical service is safe, reliable, and compliant with all applicable codes and regulations.